Hi, I am Syed. In the previous video, we were dealing with particular integral of trigonometric functions. We'll try to continue with few problems based on particular integral of trigonometric functions in this video.
Let us move on to the next question. Solve d square y by dx square plus 3 times of dy by dx plus 2 times of y is equals to 4 times of sine square of x. Let us write this in the form of the operator d square plus 3 times of d plus 2 times of y is equals to 4 times of sine square of x. The auxiliary equation will be m square plus 3 times of m plus 2 is equals to 0. Let us try to find out the roots. Once again go for mode equation. In option number 3, the coefficients that we have is 1, m square coefficient is 1, m coefficient is 3, then the constant term that you have is 2. Then if you try to see the roots over here, minus 1, minus 2 are the roots. M is equals to minus 1 and minus 2 are the roots. They are real and distinct, therefore the complementary function will be c1 e power of minus of x plus c2 e power of minus of 2x. Now let us try to find out the particular integral. It is 1 by d square plus 3d plus 2 times of, the right hand side value is 4 times of sine square of x. This can be written as, if you try to observe, this is not in the standard form. It should be sine ax, but here having sine square of x. So therefore the formula that we have for sine square of x is, sine square of x can be written as 1 minus cos of 2x divided by 2. So we know 2 sine square x to be 1 minus cos 2x, or if I want only sine square of x, I can write it as 1 minus cos 2x by 2. A similar formula in case if in place of sine square if you have cos square. So cos square of x, in that case the formula will be 1 plus cos 2x by 2. So whether sine square is given over here or cos square is given over here, accordingly you can use the formulas. So let us just try to plug in this sine square value over here. So we will be getting 1 by d square plus 3d plus 2 times of, this is 4 as it is, so you will be getting 1 minus cos 2x by 2. So if you cancel out this one, 2 1 times, 2 2 times, I can take this 2 outside. So apply this operator for the first term, 1 by d square plus 3d plus 2 times of, you have 1 here, and minus of, again apply the operator for the second term with this constant 2. So 2 times of 1 by d square plus 3d plus 2 times of, it is cos of 2x. So once again let us take this first value to be p1, the second value we'll take it as p2. So we'll try to evaluate this one. So let this equation be equation number 1. If you write down the value of p1, so the value of p1 will be equals to this one. It is 2 times of 1 by d square plus 3d plus 2 times of 1. Now you don't have any particular integral for this constant. So can I write this as e power of 0 times of x? And e power of 0 is nothing but 1. So in place of this 1, I can write this expression. Now this is of type 1 where you can replace the value of d by a. So replace the value of d by a. So what is the value of a here? A value is 0. So replace the value of d by 0. So you get P1 to be equals to 2 times of 1 by d is 0 plus here also d is 0 plus you have 2. Alright, so e power of 0 is 1. So just to use this formula, I have replaced this 1 by e power of 0. Again I am replacing back e power of 0 as 1. So you are just left out with 1 by 2 over here. So however this 2 and 2 will cancel out, you will get the first particular integral value to be 1. So P1 value we have obtained it as 1. Now similarly we need to obtain the value of P2. So P2 value will be nothing but minus 2 into 1 by d square plus 3d plus 2 times of cos of 2x. So you have to replace the value of d square by minus of a square. So here the value of a is nothing but 2. So minus of 2 square will be minus of 4. So we have P2 to be equals to minus 2 times of 1 by d square value is minus 4. So minus 4 plus 3d plus 2 times of it is cos of 2x. This will be nothing but minus 2 times of 1 by. First I'll write the positive value 3d minus 4 plus 2 will be minus of 2 times of cos 2x. So once again we'll try to rationalize the denominator. Rationalize the denominator. So if you try to rationalize the denominator, we get the value as minus 2 times of 1 by 3d minus of 2. So the rationalizing factor for 3d minus of 2 will be 3d plus 2 divided by 3d plus 2 times of cos 2x. So this will be nothing but minus 2 times of the numerator value 3d plus 2 will be as it is. The denominator is in the form of a minus b into a plus b, which will be a square minus of b square. This cos 2x will remain as it is. This can further be written as minus 2 times of 3d plus 2 divided by. So this is 3d square will be 9d square. Minus 2 square will be 4 times of cos 2x. Now we'll try to replace the value of d square by minus a square. So a value over here is 2, so 2 square will be minus of 4. So which is nothing but P2 will be equals to minus 2 times of it is 3d plus 2 divided by 9 times of d square value is minus 4 times of cos of 2x. This will be minus 2 times of it is 3d plus 2 divided by. So this is 9 times of 4 will be minus 36 and minus of 4 will be minus of 40, and this cos 2x will remain as it is. So the denominator is completely simplified. You need to just multiply this value with cos 2x. So minus 2 times of you have 3d multiplied by cos 2x, and 2 is also multiplied by cos 2x, and it is whole divided by minus of 40. You can just simplify this one. This 2 will cancel out with this 20. Negative sign will also cancel out. So you need to just simplify this one. You have 1 by 20. The constant value will take it outside. Now simplify this one. It's 3 times of differentiation of cos will be minus sine. So minus 2 sine 2x you get. And this value as it is plus 2 times of cos of 2x. So you can take 2 common from here. So it becomes 2 by 20. So you are left out with minus 3 sine 2x. And over here 2 is already taken common outside. You have cos of 2x. You can just cancel out. It's 10 times. So you have 1 by 10 times of. So first write down the positive value, which is cos of 2x, then the negative value minus 3 sine of 2x. So you got the value of P1 and P2. So you can substitute the value of P1 and P2 back in equation number 1. So you get the particular integral to be equals to, so P1 value is 1 and P2 value will be 1 by 10 times of, it is cos of 2x minus 3 sine of 2x. So that is your Pi value. Now the solution will be y is equals to CF plus Pi. So y is equals to, your CF value will be C1 e power of minus of x plus C2 e power of minus of 2x. Then you can write down the particular integral 1 plus 1 by 10 times of, it is cos of 2x minus 3 sine of 2x. So that's the required solution.